Good morning, sir. My name is Bhargavi. I am from second year EC department, and my topic in EDC is PN junction diode. Introduction to PN junctions diodes. A PN junction is a semiconductor device formed by a joining p-type and n-type materials. It plays a crucial role in various electronic devices, including diodes and transistors. Understanding its properties is essential for application in electronics and phonetics. P-type and N-type semiconductors. P-type semiconductors are created by doping with elements that have fewer valence electrons. N-type semiconductors are formed by doping with elements that have extra valency electrons. The difference in charge carriers leads to distinct electrical properties in each type. This diagram shows PN junction diode, P-type and N-type. Formation of PN junction diode. When P-type and N-type materials are placed in contact, a PN junction is formed. Electrons from N-type region diffuses into the P-type region and holes from the P-type diffuses into the N-type. The diffusion process creates a depletion region which is devoid of charge carriers. Depletion region. The depletion region is a zone around the junction where no free charge carriers exist. It acts as an insulator, preventing current from flowing through the junction under equilibrium. The width of the depletion region can vary based on the doping concentrations of the material. Here the diagram shows depletion region in PN junction diode. Here P-type material and N-type material, between we having depletion region. Built-in potential. A built-in electric field develops across the depletion region due to the separation of charges. This electric field creates a potential barrier that must be overcome for current to flow. The built-in potential is crucial for the functioning of diodes and other semiconductor devices. Forward bias condition. Forward bias is achieved by applying a voltage that reduces the potential barrier. This allows charge carriers to cross the junction easily, enabling current flow. In forward biased PN junction, the current increases exponentially with applied voltage. Here in the diagram, we can see clearly that P is connected to positive and N type is connected to negative. Reverse bias condition. Reverse bias is applied when the voltage increases the potential barrier across the junction. This condition widens the depletion region and restricts current flow to the minimal leakage. A significant reverse voltage can lead to breakdown, causing a sudden increase in current. Current voltage characteristics. The VI characteristics of PN junction diode illustrate its behavior under different voltage conditions. In forward bias, the diode conducts with a rapid rise in current after a threshold voltage. In reverse bias, the current remains nearly constant until breakdown occurs at high voltages. Here in the graph we can see we are taking voltage in x-axis and current in y-axis. That's why we called it as a VI characteristics. And application of PN junctions. PN junctions are essential components in diodes which allow current to flow in one direction. They are also used in transistors which act as switches or amplifiers in electronic circuits. Additionally, PN junctions are integral to solar cells, converting light energy into electrical energy. Advantages and limitations. The PN junction offers a simple and efficient way to control current flow in circuits. However, it can be sensitive to temperature changes and over voltage conditions. Understanding these advantages and limitations is vital for designing reliable electronic devices. Future of PN junction technology. Research continues to improve the performance of PN junctions in emerging applications. Innovation in materials and design are leading to faster and more effective devices. The future of electronics will likely rely heavily on advancement in PN junction technology. And thank you, sir, for listening my presentation.